Hi, hello students. Welcome back to India's most comprehensive online learning platform, Byjus Exam Prep. This is Anil Prasad Surampudi, and in this session, I just am going to, give you a very good idea on the process synchronization. So in this session, we're going to completely discuss about the process synchronization and the the needs for the process synchronization and the other things. So let me start the session straight away. So I welcome you all to this GATE fundamental series in which we actually are going to completely, perfect our fundamentals for our preparation for the GATE 2025 and 2026. Because whenever you're preparing for the GATE exam, it is highly essential to have your fundamentals correct, fundamentals right. So the basics of every subject must be very, very perfect indeed. Then from then you will be able to start your preparation to the level that is actually desired to crack the GATE exam. So Byjus Exam Prep taken this initiative to perfect the basics of all of you those people who actually are aspiring GATE 2025 or 2026. In this series, now the current today's topic is the operating system, and the subtopic is the subject is operating system, and the topic is synchronization, which is a very important topic in operating system. Rather, which is sometimes from the people's perspective can be considered as one of the difficult topic in the operating system. So let us get into the details of the process synchronization, how we will be able to get into the complete necessary details of the operating system. We're going to understand it right now. Okay, so this is all about myself. This is Anil Prasad Surampudi. I do have a 13 plus years of experience. For those people who don't know about myself, I'm a triple PG holder. I did my MS in Information Technology, MBA. I also did my MSc in Mathematics. Okay, and for the past 13 plus years, I've been training the students for the GATE exam. I train everywhere in India, and I also am taking the seminars all across India. For the past 5 years, I've taken more than 5,000 plus seminars. I'm an expert in the computer architecture, operating systems, and programming data structures, also the verbal ability. There is an announcement coming in your way. Byjus Exam Prep is conducting a scholarship test. Hello, Pritam. Good evening. Byjus Exam Prep is conducting a scholarship test. If you can attempt this scholarship test and score good, you will be able to get 90% off across our platform on all the courses. So the date is 14th April from 9 a.m. to 9 p.m. So do get registered right now and capitalize, get most out of this scholarship test. If you score good, really understand that you will be able to get 90% off on all the courses. So do not miss this opportunity. And let me take an initiative of congratulating our toppers here. In 2024, Byjus, we got overwhelming results, and in which we secured many first ranks and second ranks and third ranks and fourth ranks under AIR 10. So some of the toppers are Shivangar from EE, Rishabh Gupta from IN, and Gautam Gudimetla, who secured second rank from PI. Now we also parallelly running a ground zero series in which in the app we are doing the same thing. That is, this is the YouTube platform. On the app platform also we actually have been initiating the same thing of perfecting your, of making your basics right. So let us get into the details of the synchronization. Let us dive into the topic of synchronization. Okay, so shall we start? Yeah, shall we start? So first of all, let us understand what are the necessary details why we do require process synchronization. In this session, we're going to understand a background, critical section problem, and Peterson solution, various solutions for the critical section problem also. Now, first of all, understand why, what exactly is this process synchronization. The thing is, the biggest problem for the operating system is the concurrency. Concurrency, if you can ask me what is concurrency, why it can be a problem, I'll tell you. That is, when you look at the operating system at any point, listen to me carefully, at any point the operating system is going to load too many programs in the main memory. Let us say this is main memory and this is our CPU. Okay, now for execution, operating system loads many programs in the main memory. Program P1, P2, P3 can otherwise also be called as a processes. Now when executing these processes, now operating system needs to execute them concurrently. What is concurrency? Concurrency meaning initially operating system selects one program, say P1, and send the program P1 into the CPU for execution. After executing for some time, immediately operating system will switch to another process. Before its completion, it will switch to another process. Before its completion, it will switch to another process. So this is what concurrency. What exactly is concurrency? Concurrency meaning before execution of any process, operating system will pull that process back to the main memory, and one more process will be sent into the CPU. Why concurrency is required? Concurrency will give an illusion to the user such that all the programs are executing parallelly, but those are not executing parallelly. In a single processor system, only one process can execute at any point of period. Rather, the operating system is executing them concurrently. What is concurrency? First, P1 will be sent. Before P1 completely executes, it will be preempted back. It will be pulled back into the main memory. Right then, P2 will be sent. Before it gets completed, it will be pulled back. One more process will be sent. So, operating system in this way is going to switch in between the process very rapidly. So, that means it is executing them concurrently. That means user will get an illusion that all these programs are running parallelly. No, those are not running parallelly. Those are running concurrently. Of course, this is an advantage, right? How this advantage can turn out to be a disadvantage, we will understand right now. Okay. Now, let us understand. This is not the thing. It's great. Let me tell you something. The thing is, follow me carefully. You will understand everything. Here, this is my main memory. Now there are processes P1, P2, P3, and so on, Pn. Several processes have been loaded in the main memory. Right then, we do have a CPU. In CPU, understand carefully, only one process can execute. Only one process can execute. Now, initially, operating system selected P2 because of the, because considering so many factors, one process will get selected based on the priorities, based on the arrival time, based on, several parameters in the system. One process will get selected for execution. Say, at this point, P2 has been selected and sent into the CPU. Now, understand carefully. Generally, if there is no concurrency, P2 will execute in the CPU as long as it is needed to execute. Okay, once if it completely finishes, then operating system will select the next process to execute. But in a concurrent system, all our systems are concurrent systems. In a concurrent system, before P2 gets finished completely, for example, P2 is of 100 instructions. Before all these 100 instructions finishes, let us say P2 finishes only 2 instructions. Even then, P2 will be pulled back and sent back to the main memory. One more process will be sent into the CPU. Let us say P3 is executing right now. Before P3 executes, once after it executes 2 or 3 instructions, again it will be sent back to the main memory. One more process will be sent into the CPU. Here, by this, user will get an illusion, user will get an impression, all the programs are running parallelly. This is called concurrency. Why would this be a disadvantage? Understand carefully. For this, we need to understand something called, the resource requirement of a process, resource need of a process. Let us say when a process P1 wants to execute, the moment process P1 is created, process P1 requires several resources, a certain number of resources. What these resources? These resources includes CPU time, memory space. Kritam, you there? And IO devices and the files. Okay, as long as P1 is executing, these resources required by the P1 will be provided by the operating system. Now the thing is, when P2 enters into the system, there is, let us say there is one more process P2. When it gets created, some certain resources, CPU time, memory space, IO devices will be allocated to P2. Now understand, the moment any process gets created, it will get its share of the resources. A certain set of resources will be given to a process, but those resources will completely be exclusive only to that process. For example, I am a process, I will have my share of the resources. I will have my CPU time, I will have my memory space, I will have my, file that I'm going to use during my execution. I also will have some IO devices during my execution. But understand, all the resources that are provided to me are only provided to me. Same times when I use a specific resource, that specific resource cannot be allocated to any other process. For an example, when I'm P1, let us say I'm P1, I'm executing. Now a printer has been provided to me. Excuse me. There is a process P1 using a printer right now. This printer which is given to a process cannot be given to any other process as long as P1 is using. Okay, so understand carefully. Whenever a process is created, that process requires exclusive resources. Okay, so that means this process is an independent process. What is an independent process? An independent process will get its own share of the resources that are not shared by any other process. This is called exclusiveness of the resources, rather independency of a process. But sometimes what may happen is, let me clear this, but sometimes what may happen, in main memory there are several processes. Process P1, P2, P3, P4 and so on Pn. There are several processes. Most of the processes are independent, but sometimes some processes would like to communicate with each other. In our case, there are two processes, one is P2 and one more is, let us say, P9. Okay, this P2 and P9 would like to communicate with each other. Now these are no more can be considered as an independent process, rather these are dependent processes. These are communicating processes. Okay, rather these are cooperating processes. Now, what is the difference between an independent process and a communicating process? When two processes would like to communicate with each other, operating system should provide this communication, should establish communication in between these two processes by somehow or the other manner. Most of the times, operating system will establish a communication in between these two independent processes by means of a shared memory. What is shared memory? Understand carefully. Now, P1, rather, here in our case, P2 and P9 would like to communicate with each other. When P2 is executing, you already knew that P2 will have its own memory, right? P9 also will have its own share of the memory, where P9 gets loaded, where P2 gets loaded in their respective memory segments. But understand carefully, P2 would like to P9, vice versa, P9 also would like to communicate with P2. There are two ways the operating system can establish the communication. One is message passing. Second one is shared memory. Okay, we're not going to discuss about message passing right now because message passing is a superficial method of communication. There will be many drawbacks of the message passing, but in this session we are going to talk about the shared memory, which is an effective communication medium. At the same time, operating system also needs to make sure that these processes are synchronized in somehow or the other manner. So let us understand this. What exactly is the shared memory? Shared memory meaning in between P2 and P9, in addition to their respective memory spaces, operating system will create a shared memory region. This shared memory region is neither exclusive to P2 nor exclusive to P9. Rather, the shared memory region will be used by both P2 and P9. When P2 wants to communicate with P9, it will write something in the shared memory. When P9 want to read, of course, it will go to this shared memory and will read it. Vice versa, when P9 wants to communicate with P2, it will write something into this shared memory, of course, from which the P2 is going to read the data. Are we clear? Do we understand what exactly is the shared memory, Hritam? Then from which I'm going to take you people into further discussion in which things will get little complicated. To understand this, you need to be with me throughout the session, and this is not a big deal. We're going to understand completely to the extent we need to understand. Clear, right? That is what exactly is the shared memory. Okay, let us clear this. And what exactly is shared memory? Shared memory meaning an area of memory shared among processes that wish to communicate. The communication is under the control of the user process, not the operating system. Now the thing is, this communication will be established in between the user process, not operating system process. Let us not talk more about this because it is going to confuse you people in some time. We're going to understand about the user process and the operating system process in some time. Now, major issue is to provide a mechanism that will allow the user process to synchronize their action when they access the shared memory. Now, I'll tell you. We completely are going to understand this shared memory, the topic of shared memory, by taking one counter example, by taking one case study. The case study is producer and consumer. The case study is producer and consumer problem. What exactly is the producer? What exactly is the consumer? Why exactly we need to call it the problem? We are going to understand right now. Okay, let us have a look at the producer and consumer problem. Okay, before I introduce you this producer and consumer problem, let us talk about two processes which we are very familiar with. Do you remember your C programming? Pritham, do you remember your C programming? To execute your C program, this C program must go through one phase. Which phase it need to go through before execution? Could you please let me know? Pritham, you there? Every time when you execute a C program or a Java program or any other program, first of all, if you can recall, this C program must be compiled, right? The C program must be compiled, right? Right after the compilation process is finished, then the C program, must be loaded into the main memory. Understand carefully. Any C program, right after you write the program, first of all, it must be compiled. In order to compile any process, we require a program which is called a compiler. Compiler is a process which is going to compile the C program. Right after the compiler is executed, then loader will execute. Okay, what is loader? Compiler will produce a byte code. Compiler will produce a byte code, executable code. That executable code will be taken by the loader, and this loader is going to put that code in the main memory. That is what a compiler and loader. Here you can understand, compiler is a process needs to execute first. Okay, the output of the compiler will be input of the loader, right? Now you can understand this compiler and loader are cooperative processes. Unless the compiler executes, loader cannot execute, because the output of the compiler, which is a byte code, will be taken as an input by the loader, and the loader is going to load this code into the main memory. That means compiler and the loader are the cooperative process. Unless these executes in an order, unless this cooperates with each other, these process cannot continue at all. Okay, so now in this very light, understand carefully about, I'm going to talk about a producer and consumer problem. Now here you can understand what is the producer and consumer. Producer is going to produce something. Producer is going to give you an output. Consumer is going to take the output of the producer as an input and is going to go ahead. Now the biggest example for the producer and consumer is our own very own process, which are compiler and loader. I hope you got a point. Now what is the producer, what is the consumer? Let me get into the details. This producer and consumer can also be called as a bounded buffer problem. So rather than this, I will write it and show you in order not to confuse you people. Okay, let us have a look at who is the producer, who exactly is the consumer. Let us have a look at. Now understand, producer is the process and consumer is the process. This producer and consumer are going to use one shared buffer. Okay, understand carefully. Producer and consumer are essentially the processes. When the producer executes, it's going to write some data into the buffer. Buffer is, let us say, buffer is an array of some elements together. Okay, when producer process executes, it is going to write one item into the buffer. Okay, when consumer process executes, it is going to read the item that's been produced by the producer in some order. I hope you understand what exactly is the producer, what exactly is the consumer. Now, Why we will call it as a bounded buffer problem or shared memory problem? I will tell you why producer and consumer should be treated as a problem initially. See, either a producer or a consumer initially should be, of course, those are processes, right? Now understand where these processes are available. These processes are available in the main memory. These are available in the main memory. There is a producer and there is a consumer. Now this is our CPU. Initially, who should get into the CPU for execution? Producer should get into the CPU for execution, followed by the consumer. But do we have any guarantee such that producer will be scheduled first, followed by the consumer? No, there is no such guarantee that producer will be scheduled first, followed by the consumer, because there is a scheduler in between. Let us say there is a scheduler. Okay, how the scheduling is going to happen in the system? Scheduling is going to happen based on the priorities. For example, our operating system is using shortest job for scheduling algorithm. This shortest job for scheduling algorithm is going to schedule the process which are shorter. Shorter process will be given more priority. Longer process will be given less priority. Now, no matter which algorithm you are using, that algorithm is going to schedule the process according to some priorities. So, which is going to get scheduled first, which is going to schedule next is completely a call of this scheduling algorithm. So, there is no such guarantee that producer will be scheduled first, followed by the consumer, right? Consumer also gets scheduled first, followed by the producer. Now, what may happen if the consumer gets scheduled first before the producer starts his production? For an example, okay, my scheduling algorithm based on the priorities, it wanted to go ahead with the consumer. When the consumer gets scheduled first, obviously the consumer cannot do anything because no production has happened. Even then, if the consumer got scheduled first, obviously it is going to read something. What is there to read? It needs to read the first element. Do we have anything in this element? No, there is nothing in that first location of the array. But still, since the consumer needs to consume, what it will consume? It is going to consume a garbage value. If there is nothing in a memory element, we expect a garbage value to be available in that specific location, right? So with that with respect to that, obviously when consumer gets scheduled prior to the producer, consumer is going to read a garbage value, right? So this is the first problem. Initially, producer should schedule first, followed by the consumer. Unless producer gets scheduled and at least produce a single element, there is no point in scheduling the consumer. If he gets scheduled, obviously he is going to read a garbage element. This is the first problem. Consumer cannot get scheduled prior to a producer. And the second thing is, for an example, let us say the producer and consumer, our scheduling algorithm keep on scheduling only the producer but not the consumer. When producer gets scheduled for once, he will get into the CPU, he is going to produce an element. Okay, every time when he executes in the CPU, he is going to produce one element. If we schedule for once, he is going to produce one element. For an example, my scheduling algorithm decided to go ahead with the producer. Producer went into the CPU, executes for once and produced the first element. Element 1 has been produced. And then he went back. Now what my scheduling algorithm wanted to do here, it want to schedule the producer again. Of course, it may do so because scheduling will be done by the priorities. Let us say producer has got more priority than the consumer in addition to some other process. Now my scheduling algorithm scheduling producer and some other process but not the consumer. So the producer is keep on getting scheduled into the CPU. When he gets into the CPU, he will produce one element. Okay, second time when he gets into the CPU, he produces second element. Third time also he got scheduled, he produced the third element. Fourth time, fourth element. Fifth time, fifth element. Now you can see buffer is completely full. If the buffer is completely full, there is no point in scheduling the producer for more time. Why? Because if the producer gets scheduled for one more time, since he needs to produce one element, he will definitely produce an element in this location. I hope you completely got this. That is, if the producer keep on getting scheduling, if keep on getting scheduled by the scheduling algorithm, at some point buffer will completely be full. If the scheduler gets scheduled for the next time, he is going to overwrite an element which has already been produced, not at consumed by the consumer. So far, consumer has not yet been scheduled at all. So the producer is going to overwrite one of the element has already been produced but yet to be consumed by the consumer. Okay, so these are this is the first problem that to be addressed. What are the two processes? What are the two problems? First problem is consumer cannot get scheduled before the producer starts its production. Second thing is producer cannot keep on getting scheduled more than that of the buffer's size of the buffer. Now the buffer size is equal to 5. Producer at max can only get scheduled for 5 times. If he scheduled for the 6th time before, consumer gets scheduled at least for once, producer is going to overwrite an element which is yet to be consumed by the consumer. Again leads to chaos, right? Now, this is the first problem that is to be addressed. Here, producer and consumer should be scheduled in a proper order. Anyhow, this guarantee will not be given by the scheduling algorithm. The scheduling algorithm can never tell you that it is going to schedule producer first, followed by the consumer. Nor it is going to give you a guarantee that producer cannot keep on getting scheduled more than that of the size of the buffer size of the buffer. So understand carefully. When we are writing the programs, when we are developing the application, there may be several producers, several consumers in our very what do you call application. Understand this. In real time, where exactly are going to face this issue? Tomorrow, right after you finish your graduation, you will be a software developer, right? In software development, what you will do? You will be developing the applications, right? Let us say you are developing an app. In an app, definitely there will be several producers, definitely there will be several consumers. At least there will be one producer, at least there will be one consumer. When this application loads into the main memory for execution, obviously we need to make sure that producer and consumer are going to execute in some order. Since the order of execution is not guaranteed by our scheduler, we need to take a necessary care that in the program itself, we will stitch the producer and consumer together with a specific module by which the order of execution is guaranteed. Now what we need to do is, we need to make sure that that order of execution is guaranteed by the program. Being a programmer, you should be able to write an additional module by which producer and consumer will be restricted to their constraint. What is the constraint of the consumer? Consumer cannot get scheduled before the producer starts his production. Constraint for the producer is producer keep on not getting scheduled more than that of the buffer sized elements. So we need to restrict the producer and consumer to their respective constraints so that execution will be proper, execution will take some order. So we need to make sure that the order of execution is addressed in both producer and consumer. Now let us talk about this order of execution. Initially in this session, we are going to discuss about the order of execution, how we will be able to maintain the order of execution, how we will be able to restrict the producer and consumer to the respective constraints. Understand carefully. Let us understand that we are writing the code for the producer, we are writing the code for the consumer in a specific process, in a specific application. Producer when executing, it cannot execute more than that of size of the buffer size of the buffer. Consumer during the execution, it needs to make sure that producer at least executed for once and produce one element before which consumer cannot execute. So we need to restrict producer and consumer to their respective constraints. Understand how we are going to do it. See, what we are going to do is, we are going to use one common data structure. Okay, I'll show you the data structure here. Understand carefully. Here I'm going to define a macro. The macro is the buffer size. The buffer size is equal to 10. But I will restrict this buffer size to 5 to make the thing simple. I'm using a buffer size which is equal to 5. Okay, right then, I just am defining a structure name item. I'm defining a structure named item. In this structure, I have two elements. I have three elements in fact. One is buffer array. One is buffer array. The size of the buffer is equal to 5 because what is the size parameter passed into this? We pass the parameter as this macro. The macro is 10, right? So buffer size is equal to 5. Sorry, I'm restricting this to 5. Buffer size is equal to 5. Then I'm using two variables. What are those variables? Variable integer in is equal to 0. In out also is equal to 0. I'm using two integer variables. Okay. So once again, we are about to stitch producer and consumer to their respective constraints. When these producer and consumer loaded into the main memory, consumer will have to make sure that in the buffer there is at least one item. And the producer, when he gets into the memory, he needs to make sure the buffer is not completely full. If buffer is completely full, he cannot execute. Have you got a point? So in order to restrict the producer and consumer to their respective constraints, initially we need to use some common data structure. Those common data structures are, we define a hash defined buffer size is equal to 5, and then we defined a structure with three elements. First element is the array. To that array, this is the buffer, okay. Into that array, producer will produce. From this array, consumer will consume. And we use two integer variables, namely in and out, which actually are initialized to 0. Then how these actually are going to work, let us have a look at. Now, the code for the producer. I'm going to show you the code for the producer. Here, let me draw the buffer. This is the buffer with 5 elements. 1, 2, 3, 4, 5. So understand that we have int in is equal to out is equal to 0, right? What is this in and out? In and out are the logical pointers to the elements of the buffer. These are not the actual pointers. These can be considered as the logical pointers. So here understand, when the buffer size is equal to 5, initially this is 0, this is 1, this is 2, this is 3, and this is 4. Now you can expect this in and out actually are pointing to the first location. Okay, in is equal to 0, out is equal to 0. Both are pointing to the first location in the buffer, because in and out are the logical pointers to the locations of the buffer, to the items of the buffer. Now understand, we need to write the code for the producer. Understand carefully. Before the producer starts his production, he needs to make sure the buffer is not completely full. Okay, I'll tell you. Now, producer, while true, you understand this while true. While true restrict a code whenever a while statement is satisfied, and while statement is satisfied, then an event occurs. I'll tell you right now. Now there is a while statement. Before this is a production. This is where production happens. Buffer in is equal to next to produced, meaning this is the item which is going to be produced by the producer. Where this item is going to get produced? In the buffer where in is pointing, right? Where in is pointing? In is pointing at 0. Clear? In is pointing at 0. So the next produced item will get transferred to the buffer array where in is pointing. So obviously the first item that is going to be produced by the producer will be produced here. Now, what is the restriction? Restriction is the producer will not produce if the condition gets satisfied. The first thing is the condition. We are going to restrict the producer. If the condition in the while loop gets satisfied, producer will be caught in the infinite while loop. You can see this. If in plus 1 percentile buffer size equals to out, you can see there is a semicolon. That semicolon restrict the producer. That semicolon is going to trap the producer in the infinite while loop when this condition gets satisfied. What is the condition? What is the condition is, I will write it here clearly. In plus 1 mod buffer size equal to out. If the condition gets satisfied, if the condition meaning this condition says buffer is full. If the buffer is full, producer will not be able to do anything because he will be caught in the infinite while loop. Let us understand this condition. What is in? In is equal to 0. 0 plus 1 is equal to 1, right? 0 plus 1 is equal to 1. 1 mod buffer size. What is buffer size? Buffer size is equal to 5. If 1 mod buffer size 1 mod 5 equal to buffer size. If 1 mod 5 equal to 5, then the producer will not be able to do anything. But here condition did not get satisfied because in is equal to 0, 1 is equal to 1, 0 plus 1 is equal to 1, 1 mod 5 is equal to 1 but not 5. Okay, just a minute. Here what is it? In plus 1 mod buffer size is equal to out. Let us plot the value. In plus 1 is equal to 1, mod buffer size is equal to 5, equal to what is out? Out also is equal to 0, right? 1 mod 5 is equal to 0. If the condition gets satisfied, producer will be caught in the infinite value. Okay, so since this condition did not get satisfied, producer will not be caught in the infinite value. Rather, he will be able to execute this code. He will come out of the while loop and he's going to execute this code. Buffer in equal to next produced. This next produced, this is the item that is going to be produced next, will get transferred. Hi Purni Mallikarjuna. Yeah, this next produced element will get transferred to the buffer. Where the buffer? Where the in is pointing. So item 1 will get produced here. Right next. Again, what will happen? The condition gets checked. In plus 1 mod buffer size. What is in? Then after which what happens? In gets increased. In is equal to in plus 1 mod buffer size. What is in? In is equal to 0. Sorry. What is in? In will be equal to in plus 1. 0 plus 1. Then in will be equal to 1. Okay. In plus 1 mod buffer size. This is equal to 1 mod buffer size. 1 mod 5 is equal to 1. Then in gets incremented. Now when the producer producing again, he will be able to produce here item 2 because the condition gets failed. Why condition gets failed? Same. Condition gets failed because this while condition did not get satisfied. What is that? In plus 1. In is equal to 1 right now. 1 plus 1. Mod buffer size. What is buffer size? Buffer size is equal to 5. Equal to out. What is out? Out is equal to 0. So 2 mod 5. If it is equal to out 0, then the producer will be caught in the while loop. No. 2 mod 5 is equal to 2 but not equal to 0. Obviously, producer will be released from the while loop and he will be able to produce the second item. After producing the second item, in will get incremented again. In will be equal to 2. Okay. So understand carefully. Producer will be able to produce 0, 1, 2, 3. Hello Ray. Good evening. Item 3 will be produced here. Item 4 will also be produced here. This is item 1, item 2, item 3, item 4. Right after 4 items have been produced, in will get updated to 4. Then what is going to happen? I will show you right now. Don't go anywhere. Stay with me. I am going to show you right now. Yeah, listen to me carefully. Now, in is equal to 4, right? Now, in is equal to 4. Now, this time producer got scheduled for one more time. Hello, Rajeshwari. Good evening. Yeah, I hope okay, for you, operating system is not finished, right? So, be here. Understand carefully. The thing is, producer is being scheduled for one more time. Understand how it is going to happen. So far, he got scheduled for 4 times. Now, for the 5th time, what exactly is going to happen? Let us have a look at. When the 5th time producer has got scheduled, he is going to execute the following code. Immediately, the first line of code that he is going to execute is the condition in the while loop. Now, when you have a look at condition in the while loop will get satisfied. Why? Because in, what is in? Right now, in is equal to 4. Okay, plus 1. Mod, what is the buffer size? 4 plus 1 mod buffer size. Buffer size is equal to 5. 4 plus 1 mod 5. If it is equal to 0, then the producer will be caught in the infinite while loop. Obviously, that is correct. Why? Because 5 mod 5 is equal to 0. Yes, the condition gets satisfied. When the condition gets satisfied, the producer will be caught in the infinite while loop. Yes, right? So, obviously, the objective is fulfilled. What is the objective? We need to restrict the producer to his constraint. What is the constraint? The constraint is he should not be producing even though he got scheduled more items than the buffer size. In the other words, understand carefully, buffer size is equal to 5. There is a consumer to consume the buffer elements which actually have been produced by the producer. So if we schedule for 5 times, total 5 elements will be full. If we get scheduled for the 6th time before the consumer starts its consumption, I hope you got the point. Some people, they joined right now. Understand carefully. I'm a producer. There is one more consumer. When I enter into the CPU, I will produce one item. So what happens is, my scheduling algorithm keep on scheduling me. Because of the priority, I'm given more priority than the consumer. So I just keep on getting scheduled. When I got scheduled, what happens? I keep on, just producing the elements. But at some point, what may happen? I reach to the threshold. Total size of the buffer has been reached. I produced all the elements. Now I cannot produce one more element, although I got scheduled. Now I am bound to my restriction. The moment I reach to 4, I will not be able to produce any more element because I will be caught in the infinite while loop. I hope you got the point. Okay. So if I have to get released, at least consumer should be consuming one single element. Then only I'll be getting released out of the while loop. So we are able to stitch the consumer to his respective constraints. Next thing is the consumer code. Consumer code is very simple. We don't need to think too much about a consumer code. Consumer code is here, for which I'm going to draw total 5 elements, 0, 1, 2, 3, 4 elements. See, when the consumer gets scheduled, he is going to get restricted for one condition, that is in is equal to out. When in will be equal to out, simple. Initially in is equal to 0, out is equal to 0, right? That means producer did not start its production. Okay, obviously consumer will not continue. He will be caught in the while loop. While in is equal to out, he will be caught in the infinite while loop. So I'm the consumer. Before I get into actual consumption, I will check if in is equal to out. If it is equal to out, I will be caught in the infinite while loop. I will not be coming out of the infinite while loop. Simple. When in will be equal to out, there are 2 circumstances under which in can be equal to out. The first circumstance is buffer is completely empty. Producer did not start his production. At that time, in will be equal to 0, out will be equal to 0. Second thing is, the items that have been produced by the producer have already been consumed by myself. Then also in will be equal to 0, out will be equal to 0. So then let us say initially there are 3 elements, item 1, item 2, item 3, meaning there are 3 elements. So at that time, what is in, what is out? In will be equal to 3, in will be equal to 3, out will be equal to 0. Right? Out is at 0, in will be equal to 3. Mind you, every time right out of production happens, in is being incremented. In is equal to in plus 1, right? So every time after the production happens, in is getting incremented. Now I would like to consume. I will check in is equal to out. No, in is not equal to out. Out is equal to 0, in is equal to 3. So what will happen? I will come out of this while loop and I will consume. I will consume. From where out is pointing. Out is pointing at 0. From the location out is pointing, I will transfer the element to one variable which is called next consumed. I hope you got a point. This element from out location, from the buffer, will get transferred to the next consumed. That means one item has been consumed. Right, then what I'm going to do, being a consumer, I will update out. Out is equal to out plus 1 mod buffer size. What happens now? Out is equal to out plus 1 mod buffer size. So out will come here. Out will come here. So whenever in is equal to out, that means that consumer and producer, consumer consume all the elements as produced by the producer. At some point, in and out both will be equal to 3. Why? Because if the consumer keep on getting scheduled, he will consume the first element, then out will be equal to 1. He will consume the next element, then out will be equal to 2. He will consume the third element, which is the final element that has been produced by the producer. Then in is equal to out is equal to 3, right? When both in is equal to out is equal to 3, that means that there is no more item to consume. Even if I get scheduled for one more time, I will not be able to consume anything, because in is equal to out, which is the condition of the while loop. When the condition gets satisfied, I will be caught in the infinite while loop. I hope you got the point. That is, producer has got restricted to his respective constraint. Consumer also has restricted to his respective constraint. So the first task is accomplished. What is first task? The first task is to orderly execute producer and consumer to their restriction, to their constraints. The constraint of the producer is he should not be producing the elements more than that of the buffer size, although he keep on getting scheduled prior to the consumer getting scheduled at least for once. The restriction for the consumer, the constraint for the consumer is he cannot consume an element before the production happens. If you do it, he is going to consume a garbage value. So consumer should not go ahead, should not continue if there is no element in the buffer. Producer should not continue if the buffer is completely full. So the first objective has been achieved. Okay, but in this solution that we discussed right now, there is a small loophole. We're going to discuss about a loophole, how to overcome the loophole in the next session. I hope you understood this session. I hope you completely involved in this session and understood the extent that I desire you people to understand. With which we have come to an end of this session. In the next session, I'm going to take forward you exactly from where we stopped this session. Thank you so much, and that's it on the session. If you do have any more doubts, I'll send you this PDF. Are you in my group? Are you in my Telegram group? Are you in my Telegram group? So I'll share my Telegram group in the next session. Otherwise, just look at this comment and after some time, look at this comment section of this video. I'm going to ping my Telegram group here. You can join the Telegram group and get this PDF. I'm going to post the PDFs in the Telegram groups. Thank you so much, and that's it for the session. And if you are aspiring GATE 2025 and 2026, do get registered to BYJU'S exam prep to get all these live classes, recorded lectures, study material, practice quizzes, and mock test. Okay, and we have upcoming batches coming soon. To get registered, give a call to this number. Also, you can fill the counseling form available in the Dropbox. Okay, you also can parallelly call this number. Okay, and that's it on the session. Thank you so much. Shall we leave? Yep, good night.